Okay, folks, we're going to reunite and we're going to take care of the second part of 9.5, rationalizing a single term denominator. In the first set of exercises, we were rationalizing denominators that were numerical. And now we're going to rationalize denominators that are variable expressions. And they're going to be handled in the same way. We just have a little bit, maybe a little bit more thinking that we have to do, but it's going to work out. Let's take a look at problem number 5. The radical of 40h cubed over 3k. Now, we can't have a fraction, but it doesn't mean that we can't reduce if it's able to be reduced. We cannot do anything with the 40 and the 3. And we don't have any h's in the denominator, and we don't have any k's in the numerator. So there isn't any simplifying that can be done with this fraction. So we'll make use of the quotient rule of radicals and split this up and get it down to this form. The radical of 40h cubed divided by radical of 3k. Now, if we look at both numerator and denominator, we realize that we're stuck with a radical in the denominator and we're going to have to rationalize. We can also take a look at this numerator and possibly see that this power of h in the numerator is an h cubed, and that h cubed, within that, there is going to be an h squared that we're going to be able to remove. We can either take care of it now or we can take care of it later, and I don't think there'd be any problem with taking care of it later. Now that we've got it in this form, let's just go about the business of rationalizing this denominator. So we're going to get a time sign ready and a brand new fraction bar. And we're going to get a radical ready here and a radical ready here. Index is 2, square root. We have one factor of 3 in this original radical. We're going to need to pick up another one to gain a perfect square. So we're going to need another 3. Because we can see that 3 times 3 is going to give us 9, a perfect square. We have one factor of k here. We're going to need another factor of k. So we're going to multiply the bottom by the radical of 3k, and we're going to multiply the top by the radical of 3k, because what you do to the denominator, you have to do to the numerator. Now let me just kind of bring it down right here. We multiply these two radicals together. We're going to have 40 times 3, which is, let me get that radical there, that's going to give us the radical of 120 h to the third k. And on the bottom, we multiply those two radicals together. We're going to get the radical of 9k squared. Okay. Let's come back up here to the top. Let me just kind of rewrite that again. The radical of 120 h to the third k over the radical of 9k squared. Come down with a bar. We can go to the bottom right now because this is much less information in there, and we can just find the radical of 9k squared, which will give us a 3k on the bottom. On the top, not only within h to the third is there an h to the second, but there is also something in 120 that we can pull out. So we can use the product rule of radicals to split this numerator up, and we're going to have to do that. So I'm going to get one house ready times a second house. And let's go ahead and start with the 120. Now that's a bit large, so I'm going to come over here to the side, and let's prime factor 120. That would be 2 and 60. And that would be 2 and 30. And that would be 2 and 15. And that would be 3 and 5. We need 2 of a kind because our index is 2. We have 2 of a kind here and no more. So over here in the rational house for the 120, we'll put 4. And in the irrational house, 2 times 3 is 6, and 6 times 5 is 30. Within the h to the third, there is an h to the second that is rational, and the leftover h is by the 30. And then we have a k. We don't have enough k's there, so the k becomes irrational. Now come down. Put that 3k on the bottom. On the top, we're going to find and simplify this. This will give us 2h times the radical of 30hk. The 2 and the 3 here, nothing can touch that. We don't have h's and we don't have k's. Looks like this will do it, and it is done. And we've rationalized that. That is a little k right in there. And that would take care of that one. So you can see by this first example right here, it is a series of steps. And as you can see, you want to give yourself plenty of room on a sheet of paper to do it, to handle it, because it's going to take some time and some space. Let's take a look at another situation right here. Let's go to this. Change the index this time. 6 over the cubed root of 5. Everything has been square root up to this time. Well, it doesn't take long to look at this and say that radicand falls very, very short of being a perfect cube. Our index is 3. So we can go to rationalizing the denominator right away. Put the times sign, the bar, get it set up. Make sure that the index is placed in there. It's got to be a cube. It's got to be a cube. All right, the cube indicates 3 of a kind. We have one factor of 5 right here. We're going to need 2 more factors of 5 to create a perfect cube. We have 1. We're going to need a 5 to the second in this one. 5 to the 1 times 5 to the 2 will give us 5 to the third, which will be a perfect cube. We replace that same thing up here. Come down with one line. 6 multiplied by the cubed root of, we'll go ahead and change him to 25 right now. On the bottom, I don't think I would change it to its numerical value. I think I would leave it in this form. Over the cubed root of 5 times 5 to the second would be 5 to the third. And now let's simplify. The numerator, 6 multiplied by the cubed root of 25 over, bring down that base of 5. If we divide its exponent by its index, it's just 5 to the first, or 5, and he is done. Don't go looking at that 25 and thinking that you're going to make it a 5, because it's not square root, it's cubed root, and it's simplified. So there's 6. Let's go to 7. Let's take a look at this one. 30 over the cubed root of 3z squared. Well, none of the little factors in here are cubes. There's no consideration of reducing anything because we don't have a radical up here. So we can move right into the rationalization. Get ready. Put an index of 3 there and an index of 3 there. And let's see what we're going to need. We have one factor of 3. Our index tells us we need a total of 3 factors of 3. So we have one of them here. We're going to need 2 more that we'll put in there. We have 2 factors of z. We'll need 1 more z. What we have here, we put up here. Because if you multiply the denominator by this radical, the top has to be multiplied by that same radical. Bring a line down, and let's multiply 30 times this. We'll get 30 multiplied by the cubed root of, we'll change them to a 9, 9z. Over the cubed root of 3 to the 1 times 3 to the 2, 3 to the 3rd, z squared times z to the 1, z cubed. Bring down, I'll move it over here, 30 multiplied by the cubed root of 9z over, bring down that 3. 3 divided by 3 is 1, so that'll just stay 3, and the z. Let's step back and take a look. No, nothing here, because he's radical and he's not. But this factor of 30 can be reduced with this factor of 3. 3 will go into itself once, and it'll go into 30 10 times. Final answer, 10 multiplied by the cubed root of 9z, all of that over z. And there would be our final answer. We'll take a look at one more. Call it number 8. Change the exponent again, and let's go to this. 5 over the 4th root of 7t. Well, we can see that we're going to have to rationalize right away because there's no part of this radicand that has any perfect fourths within it. So we'll get a time sign ready. Bar, radical sign, index 4. Radical sign, index 4. That tells us that to have a perfect fourth power, we're going to have 4 of a kind of each of these. So we're going to need a total of 4 factors of 7. We have 1 right now. We're going to need 3 more. We have 1 factor of t right now. We're going to need 3 more. Put this radicand as this radicand. bar. 5 times him. 5 multiplied by the 4th root of 7 to the 3rd. 7 times 7 times 7. Well, 7 times 7 is 49. And 49 times 7 again, not 49 times 3, 49 times 7, I believe that will give us 343 t cubed. And on the bottom, we'll have the 4th root of 7 to the 1 times 7 to the 3rd, 7 to the 4th, t to the 1 times t to the 3rd, t to the 4th, and we'll get then this. 5 times the 4th root of 343 t cubed over, bring out that 7, bring down that 7, and 4 divided by 4 is 1, so just 7 and a t. Look at this factor of 5 here with what you have here, and there is nothing. And we've rationalized that denominator as well. Now, before we just kind of close this off, this came from 9.5. We will be returning to 9.5 down the road a bit, and we will be rationalizing denominators again. But when we return to 9.5, we'll be rationalizing denominators that contain 2 terms instead of 1. And we'll get to that. So when we reunite, we'll be getting back on schedule and we will move to 9.3.